Okay, Algebra 2 students, here's the plan for the next 2 days. Do what you're doing right now. Watch this video. Take notes on it. And then what you're watching now, the worksheet that I'm doing, is the same worksheet that you're going to do and complete on GradeCam. I will post this on GradeCam. I think there's around 20 questions. That's going to be your assignment for the next 2 days. This will be due on Friday. What I want to do is basically just go through each section and do a couple example problems for each, so you know how to do them, and hopefully you can kind of get an understanding of these complex numbers. So you guys have watched a couple introductory videos on imaginary numbers and complex numbers. So I think you guys now know that two big things here, that I equals the square root of -1 and that I squared equals -1, and we're going to be using these definitions throughout this sheet of paper, this worksheet. Alright, so let's look at problems 2 through 5. Alright, so problems 2 through 5, write the number as a product of a real number I, simplify the radical expression. Alright, so how do we do these? Okay, I'm going to just create my own example and do a couple. And then you apply them to the particular problems. Alright, so let's just say we have the square root of -25. Alright, so when you get a problem like this, the first thing you want to do is to break this up. Alright, and we want to break it up as the square root of -1 times the square root of 25. Alright, so you always want to pull out and write the number. One of the factors you want to be -1, and the other factors is just whatever this number is, so 25. We know that the square root of -1 by definition is I, and then we know that the square root of 25 is 5. Alright, and so let's flip this around. So we always want to write the number first, followed by the imaginary. So we're going to write this as 5i. So the square root of -25 is 5i. Alright, if we do the square root of -49, alright, let's break this up. Square root of 49 times the square root of -1. What's the square root of 49? That's 7. The square root of -1, that's I. There's your answer. One more. The square root of I don't know, 36. Hopefully this isn't one on the worksheet, but if it is, well, I'm giving you the answer. So square root of -36, rewrite this as the square root of 36 times the square root of I. So that's going to be 6i. Okay. Now, sometimes it's I'm giving you basically numbers that are perfect squares. So sometimes it won't be that easy. So let's do one where it's a little bit more difficult. So let's just say we have the square root of -24. Alright, so write down the square root of 24 times the square root of -1. Alright, and now here, so the square root of 24, it's not a perfect square. But does 24 have factors that are perfect square? That is a perfect square, and the answer is yes, it's 4. So we can rewrite this as the square root of 4 times the square root of 6 times the square root of -1. So the square root of 4 is 2, the square root of -1 is I, and the square root of 6 is simplified. So there's your answer. How about the square root of -50? Alright, break this up. Square root of 50 times the square root of -1. Alright, it's 50. That's not a perfect square. But what we can do is recognize that 50 one of the factors of 50 is a perfect square. That's 25. So we can rewrite this as the square root of 25 times the square root of 2, and then bring this down here, times the square root of negative 1. So the square root of 25 is 5. The square root of negative 1 here is I, and then square root of 2. Alright? So that should help you with these problems right there. Okay? Alright, the next set of problems, come on. Alright, the next set of problems here, we have to multiply or divide as indicated. Alright, so I'm going to do a couple examples that look at these types of problems. I'm going to start with multiplication. Alright, the first example, we're going to do the square root of negative 8 times the square root of negative 12. Alright, now you might be tempted to multiply, to say, okay, well, I'm going to multiply negative 8 times negative 12, that's going to give me a positive underneath the square root, and then I can go from there. But you cannot do that. What you have to do is you have to break these down individually because you're taking the square root of a negative. Alright, so the square root of negative 8 is going to equal the square root of 8 times the square root of negative 1. Alright, we're breaking it up just like we did with the previous examples. Over here, the square root of negative 12, break that up. That's the square root of 12 times the square root of negative 1. Now, square root of 8. What factors of 8 are perfect squares? Well, 4. So we're going to take the square root of 4 times the square root of 2. And then we're going to multiply, bring this down, by the square root of negative 1. And then over here, we have the square root of 12. Well, 4 is also a factor of 12, so we're going to do the square root of 4 times the square root of 3. Bring the square root of negative 1 down. Alright. And now what we can do is go ahead and say, okay, square root of 4 is 2. Square root of 2 cannot be simplified further. And then the square root of negative 1 is I. So really this simplifies to 2I square root of 2. And then over here we have 2, so then we're going to multiply it by 2 square root of 3, and then the square root of negative 1 is, well, that's I. Alright, so we have 2I square root of 2 times 2I square root of 3. Let's go up here with it. So 2I times 2I. Alright, so when you're multiplying complex numbers, remember we have to do what's out in front here. So the 2i's, we have to multiply those separate from what's here underneath our radical. So 2i times 2i, that's going to give us 4i squared. And then the square root of 2 times the square root of 3, that's going to be the square root of 6. Now, what does I squared equal? I squared equals negative 1. So 4 times negative 1 is negative 4 square root of 6. That's your answer. Okay, here's another multiplication of two radicals that have two negative radicals. Alright, so again, we cannot do this. We cannot say that this equals the square root of 40. Alright, so negative 10 times negative 4, that gives us a positive 40. Right, you can't do that. Alright, you have to, order of operations, before you multiply, you got to figure out you got to deal with the square root of negative 10, and you got to deal with the square root of negative 4. You got to figure out what that is before you go ahead and multiply them together. So that's what we're going to do. So again, can't do that. All right, so we're going to erase this. All right, so let's deal with these individually. All right, square root of negative 10. That's the square root of 10 times the square root of negative 1. All right, square root of negative 4. It's the square root of 4 times the square root of negative 1. The square root of 10. Is there a factor of 10 that's a perfect square? And the answer is no. All right, so we just have the square root of 10 that's simplified, and then the square root of negative 1 is I. So I times the square root of 10 over here. Square root of 4, that's going to be 2. The square root of negative 1, that's I. Okay, so now don't want to lose my multiplication sign there. So now we have to multiply these together. All right, so you have to do we got to multiply the I and the 2I together. So that's going to give us 2I squared. And then we have the square root of 10 times, well, 1, if you will. So it's just that right there. Okay, so 2I squared times the square root of 10. Now, what's I squared equals? It equals negative 1. So 2 times negative 1 is negative 2. And then we attach, we keep the square root of negative 10 with it. There's your answer. Okay, next couple examples, we're going to divide the negative radicals. So we're going to focus on kind of those two, how to handle those. Alright, so let's get a blank screen up here. Alright, so let's start with something like this. The square root of negative 40 over the square root of 10. Alright, so like multiplication, you just got to, before you divide, you have to deal with this, and you got to deal with this. Alright, so let's break the numerator up. So the square root of negative 40, we can rewrite that as the square root of 40 times the square root of negative 1 divided by the square root of 10. Alright, the square root of 10 does not have a factor. There's no factor of 10 that's a perfect square, so the square root of 10 is already simplified. Alright, so square root of 40. What is a factor of 40 that's a perfect square? Well, 4. So we can break that up. Square root of 4 times square root of 10 times square root of negative 1 all over the square root of 10. Now look what can happen. The square root of 10 here in the numerator cancels out with the square root of 10 in the denominator. So then we're left with the square root of 4 times the square root of negative 1. Oops, we don't need that. And so that's going to give us 2I. Square root of negative 1 is I. Square root of 4 is 2. So there's your answer. Next one. All right, let's take the square root of negative 80 over the square root of negative 5. All right, let's break up the top. We can say that that is square root of 16. So factor of 80, it's a perfect square, is 16. Times the square root of 5 times the square root of negative 1. Alright, so I kind of, to save some time, I kind of combine a couple steps there. Alright, and then we have the square root of negative 5, so that's going to be the square root of 5 times the square root of negative 1. Alright, so the square root of 16 is 4. The square root of 5 is simplified. Alright, square root of negative 1 is I, so we have 4I times the square root of 5. And then again, the square root of 5 here is simplified, so this is going to be the square root of 5 times I. Now, this is kind of why we like to put the imaginary I out in front, because we don't want it to look like we're taking the square root of 5I. So let's move it out there. Okay, numerator and denominator, square root of 5, and both cancel those out. Look at I is also in the numerator and denominator. Cancel those out. 4 is your answer. All right, so those sets of problems will help you with 8 and 9. Okay, the next set of example problems that I'm going to go over are going to help you with 10, 11, 12, 13, adding and subtracting complex numbers. We sort of did that, kind of focused that on our homework last night, so we should be good with this, but let's just go over it again just in case. Alright, examples. Let's do something like this. So let's do 8 minus 3i plus 5 minus 6i. Alright, now when you're adding these together, alright, what you kind of want to do is just imagine that there's a 1 in front of both parentheses and sort of distribute. So 1 times 8 gives you 8, 1 times negative 3i is negative 3i, and then we have a positive 1, so positive 1 times 5 is positive 5, and then a positive 1 times negative 6i is a negative 6i. Alright, so really what I did was I just distributed here, here, and there. Okay, now what we want to do is we want to combine the real and imaginary parts. So here's a real part, there's a real. So 8 plus 5, that's going to give us 13. And then we have an imaginary part, negative 3i, and a negative 6i, that's going to give us a negative 9i. Now, to write this correctly, we always want the real part in front of the imaginary as it is now, so we can circle that as our answer. Alright, next one. Let's do 10, let's do a subtraction one. 10 minus 7i minus 3 plus 4i. Alright, kind of imagine there's a 1 in front, and then now there's a negative 1 here. So distribute, so 1 times 10, that's going to give us 10. 1 times negative 7i, that's going to be a negative 7i. Let's make this look like a 10. Alright, now the negative 1 here. So negative 1 times 3 is negative 3. And then the negative 1 times 4i is going to give us a negative 4i. Alright, here's a real part, 10 and negative 3. Alright, so 10 minus 3 gives us 7. And then we have a negative 7 and a negative 7i and a negative 4i. That's going to be a negative 11i. And there's your answer. Alright, so you're almost treating the I, treating it like a variable and kind of combining like terms. Okay, next set of examples. We're going to hit on multiplying complex numbers here. So let's do some examples. First one we're going to start with 5i times 3 plus 4i. Alright, what you're going to do here is distribute. Alright, 5i times 3, 15i. A 5i times a 4i. Well, 5 times 4 gives us a positive 20. I times I is I squared. Now, what do we know about I squared? I squared equals negative 1. So we have 15i plus 20 times negative 1. So we have 15i plus actually plus negative 20. So plus a negative 20 is the same thing as minus 20. Now notice how we have the imaginary part in front of the real part. We want to switch that. So we want to switch that to negative 20 plus 15i. There's your answer. Okay, next one. Let's go 7 minus 6i times 2 minus 3i. Okay, so now we have to FOIL here. So if you remember, FOIL, the F stands for multiply what's first. Multiply the numbers that are first. So 7 times 2, that's going to give us 14. The O stands for multiply what's on the outside together. So negative, not negative 6i. It's going to be negative 7 and negative 3i. So it's going to give us a negative 21i. The I, what's inside? So negative 6i and 2, that's negative 12i. And then the L stands for multiply the what's last. So negative 6i and a negative 3i, that's going to give us a positive 18i squared. Now, let's combine. So we have 14, and then we have a negative 21 and a negative 12. So negative 21 minus 12, that's going to give us a negative 33 plus 18 times negative 1. Because I squared is equal to negative 1. Now, I did something here. Okay, so yeah. So negative 21i and a negative 12i, that gives us a negative 33i. Alright, so we don't want to lose that I there. Alright, okay, so now we have 14 plus, what do we got here? Negative 18. So 14 minus 18. That's going to give us negative 4. And then we have the minus 33i. So there's your answer. Next. Okay, this one, let's do 2 plus 3i squared. So, how would we rewrite this? We're going to rewrite this as 2 plus 3i times 2 plus 3i. Okay, because what's 2 squared? So 2 squared would be 2 times 2. So 2 plus 3i squared is going to be 2 plus 3i times 2 plus 3i. Alright, go ahead and FOIL now. First times first. So 2 times 2, that's going to give us 4. And then the outers, 2 and 3i. So here and here, that's going to give us a positive 6i. The inners, 3i times 2, that's going to give us 6i. And then 3i times 3i, that's going to give us a positive 9i squared. Alright, so we have 4 plus, alright, we can combine those, 6i and 6i, give us 12i. And then we're going to have a positive 9 times I squared is negative 1. So 9 times negative 1 is negative 9 plus 4. That's going to give us a negative 5 plus 12i as our answer. Okay, next set of problems. We're dividing by complex numbers. So 19, 20, 21, 22. Does it go any further than that? No. Alright. So, first problem. We're going to do 6 plus 3i divided by 7 minus 5i. Alright, so we never want to have an imaginary number in the denominator. So as you can see right there, we have an imaginary. We got in the denominator. We don't want that. So the trick to get rid of it, so we just have a real number in the denominator, just to multiply by what we would call the complex conjugate. So the complex conjugate of 7 minus 5i is going to be 7 plus 5i. So we're going to multiply by 7 plus 5i over 7 plus 5i. Alright, so we're multiplying by 1, but a different kind of 1. Alright, because 7 plus 5i, or 7 plus 5i, that would give us 1. So we're not changing any values here in what we're doing. Okay, so now we just have to multiply the top and multiply the bottom. So we're going to have to FOIL twice now. So let's look at this part first. So 6 times 7, that's going to give us 42, the first. 6 and 5i, that's going to give us 30i. That's the outers. The inners, 3i and 7, that's a positive 21i. And then the last give us 3i and 5i, that's 15i squared. Alright, underneath here, okay, 7 times 7, that's going to give us 49. 7 times 5i, the outers, that's going to give us a positive 35i. The inners, a negative 35i, so that's the magic of all that. As you can see, that's going to cancel out. Negative 5i times a positive 5i, that's a negative 25i squared. Alright, let's simplify. So up top, what can we combine? Alright, so we got the 42, and then we have a 15i squared. So 15 times negative 1, so that's negative 15. So we have 42 minus 15, because 15, and that's going to give us 27. And then we have a positive 30i and a positive 21i. That's going to give us a positive 51i up top. On the bottom, the 35i and the negative 35i cancel. So I have 49, and then I have a negative 25i squared. That's negative 1. So negative 25 times negative 1, that's a positive 25. So we have 49 plus 25. That's going to give us 74. So our final answer we can write, and how it's written on your worksheet, you'd have to say, okay, 27 over 74 plus 51i over 74. So you have to divide both the 27 and the 51i. Both of those terms have to be divided by 74 to give you this as your final answer. Alright, so if you got a complex number in the denominator, multiply by the complex conjugate. Alright, so let's just say, I'm not going to go through the whole problem, but so we're clear, if we had 3 plus 3i over 3 plus, let's do a minus sign. So minus 8i, you would multiply by the complex conjugate, which would be 3 plus 8i over 3 plus 8i. So the complex conjugate, it's just the sign between the real and imaginary part that switches. Everything else stays the same. Alright, finally at the end, last set of problems. Alright, we want to find the power of I. Alright, so here we go. Let's knock this out and be done. Okay, couple things here. So we know that I equals the square root of negative 1. That's what we started with. We also started that I squared equals negative 1. Alright, so what does I cubed equal? So I cubed, so if we rewrote I cubed, we can say that that equals I squared times I, or I to the first. Alright, so what's I squared equal? Well, I squared is negative 1, I is I, so I to the third equals negative I. I to the fourth. I to the fourth, we can rewrite that as I squared times I squared. Well, I squared equals negative 1, so negative 1 times negative 1 equals 1. So I to the fourth equals 1. Alright, you go I to the fifth, alright, you get I to the fifth, that's going to, so these things kind of cycle through every fourth, if you will. So I to the fifth will be what I equals, and so on. Now, what I want to do is let's find I to the seventh. Alright, so I to the seventh, what's that going to equal? So what you want to do is rewrite this, rewrite these using I to the fourth as many times as you can, because we know I to the fourth is 1. So I to the seventh equals I to the fourth times I to the third. Okay, so when we're multiplying powers with the same base, you add the exponents. So 4 plus 3 gives us 7. Alright, so I to the fourth is nice because we know that's 1. Alright, what does I to the third equal? Well, I to the third equals negative I. So I to the seventh is negative I. That'd be our answer. Alright, let's make it a little bit bigger. Let's make I a little bit bigger. So let's do I to the 22nd. And I'm going to need a little bit more room for this one. Alright, let's rewrite this as many times as we can using I to the fourth. So I to the fourth times I to the fourth times I to the fourth. So 4 and 4 and 4, that's 12. Times I to the fourth times I to the fourth. So what do we got now? 1, 2, 3, 4, 5. So that's 20. Alright, so then times I to the second. Alright, so all of these, so this is 1 times 1 times 1 times 1 times 1. So that's all going to be 1 times I squared. So this is not I don't want you to think that's a negative sign, that's a times. Alright, so what does I squared equal? I squared is negative 1. I wrote negative I. Negative 1. Alright, so I know this was long, but it covers 2 days of material. What I would do is I would watch this video. Hopefully you go back. It's divided up in sections. Hopefully we hit on enough examples to get you through the different sections in the worksheet. Now all you need to do is just complete the 26 problems, go on to GradeCam, complete the form, and you are done. Have a great spring break, and we'll see you back in a little over a week.